In the previous video, we ended with this example, and this was acetylene or ethine, depending on how you wanted to name it, common name or IUPAC. And what kind of general reagents do we need to bring into the picture in order to turn that into an E2-pentene? So here we see some stereochemistry that's very important. We need to end up with a translocation or the E location, and we needed to walk through the whole series of reagents in order to get that product. So we said, one, we have to elongate the chain. Two, we have to at least break that triple bond down to a double, because that's what we see here, a double bond. And then we've got to make sure that when we do that, we put it in a trans location and not a cis location. So what are the things that we need to do in order to get this accomplished? Well, first off, the chain elongation step should always happen first most of the time, and that includes sodium amide. So this will take my acetylene and allow me to remove a hydrogen from it and to get the acetylide ion that I can then work with. So this is going to be step number one. Well, step number two is that when I end with this acetylide ion, I now need to elongate the chain. So how many carbons should I put on there? Well, we've got a total of 1, 2, 3, 4, 5, and we're starting off with 2, so I need a total of 3 extra carbons. But you've got to be very careful in where you put these carbons. This C triple bond C really is going to be here, because this is going to be the location of a triple bond before we break it to a double. So I've got to look at what kind of groups I'm adding onto each side of that acetylene group. Well, if I take a look to the left, I've got an ethyl group up here, and if I take a look to the right, I see a methyl group here. So this is going to require 2 chain elongations. If I add 3 total carbons, well, this is going to force the triple bond on the end of the molecule, and that's not where I want it. I want this triple bond internally. I want it inside of the organic. So the very first thing that I'm going to do is maybe add in ethyl bromide. And when I do that, I'll end up with a C triple bond C, and this is connected to a CH2 and a CH3. So this takes care of the ethyl part, which is here. And now I need to start all over, and I'm just going to continue the arrow, and I'm going to go this way. And I'm going to add NaNH2 to this again. So this is step number 2. Step number 3 is I add the sodium amide all over, and this is going to give me another acetylide ion. When this happens, I then need to add a methyl group onto the other side. So this will allow me to add ethyl bromide. So my methyl group, C triple bond C, and then CH2 and CH3. So this is going to be step number 4. Now I've got this pentane, and the pentane is what I'm after. I just wrote it backward. My ethyl group is here on the right instead of on the left, but that's okay. It doesn't really matter. I still got a 5-carbon chain, methyl on one side, ethyl on the other. I now need to convert this triple bond into a double. I need to get rid of it. So first, you would want to say, well, we're going to add H2 and Lindlar. And this will allow me to take my double bond or my triple bond and convert it to a double. And it does. That is the purpose of H2 and Lindlar. And it allows me to add a hydrogen here and a hydrogen here with the double bond in between now. The problem, though, is that H2 and Lindlar gives me the cis form. And I don't want the cis form. I need the trans form. So this H2 and Lindlar is not going to be the route that I need. I need another route that I can do the trans orientation on. And the trans orientation we've talked about in the alkyne reactions, and that was the metal using sodium or lithium, either one that you want, with liquid ammonia, so NH3 at negative 78 degrees Celsius. And when I do that, the C triple bond C changes into a double. My methyl group is on one side, my ethyl group is on the other, and my hydrogens are now on opposite sides as well. And this is the product that we want. So this is going to be step number 5. So this multi-step synthesis is 5 steps. Sodium amide to add on an ethyl group to one side of the molecule. Then sodium amide to add the methyl group on the other side of the molecule. And then sodium or lithium that will add the hydrogens on in a translocation, which is what that question was after. So 5 steps, maybe not as complicated as some of the others. The only tricky part, though, is that you have to understand that 2 elongations are going to be required. If you did one elongation with a 3-carbon chain, again, that would have put the alkyne group at the end and not in the middle, which is where we wanted it. So let's look at another example. This time, let's look at another acetylene, and we want to know what can we add reagent-wise in order to get a product that looks like this. So stereochemistry is going to be involved a little bit again, and we'll put a CH2CH3 group here, and we'll put a CH2CH3 group here, and we'll put a hydrogen there. First, we've got to remember what this was called. And if you forgot what this was called, it was called an epoxide. So anytime we get this oxygen containing in a ring like this oxygen hanging on to 2 carbons at one time, that is called the epoxide functional group. So this is going to require us to dig back a little further into the reactions of alkenes and figure out how to make an epoxide. Not only that, but I have an elongation step as well. So the elongation step, I end up with 2 carbons, and then if I look at my longest carbon chain, 1, 2, 3, 4, 5, 6, I'm going to end up with 6 carbons in total. So I'm going to have to elongate, which is probably the first thing that I need to do. And then I'm going to have to get rid of the triple bond, because that's what I'm starting off with. And then I'm going to have to add my epoxide containing group. And we've got to figure out how to do that the best way possible. Not only that, but these hydrogens have to go on, if I look at the structure, to the same side. So the same side is cis. So cis is going to be very important for me to remember as well. Okay, so let's figure out how to start this off. If I take a look at my C triple bond C, well, this is the area that my functional groups are going to be added on to. And if I take a look at this molecule, that's probably where my C triple bond C is going to be, because that's where my epoxide has been added on, and we can actually add on ethyl groups to that position as well. So the very first thing that I need to do is elongate the chain. So I'll add NaNH2, and that gives me carbon, triple bond carbon with a negative. And then I need to elongate the chain. On one side, I need to bring in the ethyl group, so ethyl bromide would work there. And I've got H, C, triple bond C, CH2, and CH3. Well, I need to add 2 more carbons onto the left, so I need to elongate again. So I add more sodium amide. And when I do that, that gives me a negative on that end now that I can play off of. So when I do that, I'll add another ethyl bromide, CH3CH2Br, and that gives me CH3, CH2, carbon, triple bond, carbon, CH2, and CH3. Well, the epoxide reaction happened in alkenes, so I need an alkene before I can change it to an epoxide. So I need to take this triple bond and I need to convert it to an alkene, but I need to pay attention. This is a cis form, so H2 and Linlar would work here. So H2 and Linlar will allow me to convert this alkyne into an alkene that has the hydrogens on the same side. And then once that happens, I can then turn it into an epoxide. that required a peroxy acid, C double bond O O O H, and the peroxy acid would come through, break the double bond for me into a single bond, and this would have the oxygen on it. So let me fix this molecule a little bit. This is going to be a carbon that shares the oxygen here, and then that carbon is going to have my CH2 and CH3 on it. So there's the product generation and the steps required in order to get it.